Here's a gas stoichiometry problem. This is the sort of thing where we're given an equation like this, we have to calculate the amount of chemicals that are going into the equation or coming out of it. What I have right here is the equation for the combustion, also known as the burning, of natural gas, which is methane. This is like what's in a Bunsen burner maybe, in a laboratory, or in your stove if you cook with gas. So what I have here is CH4, methane, natural gas, combines with oxygen, O2, and this makes, as well as a lot of heat, CO2, carbon dioxide, and H2O, which is water. So here's the combustion of natural gas. The question that I'm asked, the question that I'm working with here is how many grams of H2O, of water, will be produced by 58.2 liters of CH4 at STP. Assume an excess of O2, which means I have all of the oxygen gas that I want. So I have a certain amount of this that I'm putting in, of methane or natural gas, and I want to know how much water I'm going to be getting out of it. I want to break this down into the steps that I'm going to use to solve it. I'm going to sketch out a roadmap of the steps before I do the math, and then I'm going to go through the calculations. So, the first thing that I have to do is keep in mind that a chemical equation like this is good to have, but I can only put moles into it. The problem gives me an amount of CH4, not in moles, but in liters. So the first thing that I have to do is I have to go from liters of CH4 to moles of CH4. Since the problem states that it's at STP, I can use the fact that 1 mole takes up 22.4 liters of space, and that's how I'm going to convert from liters of CH4 to moles of CH4. So this is my first step. After I get my moles of CH4, the next thing that I want to do is find out how many moles of H2O I'm going to get out for that number of moles of CH4. So that's what I say here when I say that our next step is going to be to go from moles of CH4 to moles of H2O. I'm going to use a chemical equation to find out how many moles of H2O I'll get for each mole of CH4 that I put in. Finally, I'll then know the moles of H2O, but the problem asks me not for the moles, but for the grams. How many grams of H2O am I going to get out? So the last thing that I'm going to want to do is I'm going to want to take the moles of H2O and convert that to the grams of H2O. And I can use that by using the molar mass, which is one mole of H2O is 18 grams. And that's how I'm going to do that last conversion. So these are my 3 steps. Liters of this to moles of this, CH4 to H2O, and then finally moles of H2O to grams of H2O. Let's get started with the calculations. So the first thing here, 58.2 liters of CH4. Again, it says that it's STP, so I can take advantage of this really convenient rule. That at STP, which is 0 degrees Celsius and 1 atm of pressure, 1 mole of any gas takes up 22.4 liters of volume. So this means that there are essentially 2 conversion factors that I can write that say 1 mole is 22.4 liters. I can do 22.4 liters above 1 mole, or I can do 1 mole above 22.4 liters. Let's see which I want to use. I'm going to start with 58.2 liters. To convert this to moles, I want to use the conversion factor that is going to let me cancel out liters. So I want liters to end up on the bottom. That means that I'm going to use this version of the conversion factor. So 1 mole on the top divided by 22.4 liters on the bottom. Now I have liters up here and liters down here, so they cancel out. And when I do that math, my answer is 2.60 moles. Since mole is the unit that I'm left with, that's my final answer here. Okay? I rounded this to 3 significant figures. So, when I do this part, I find that I have 2.60 moles of CH4. Great. So we've cracked the first part of the question. Let's now go on to the second part. Now that I know the moles of CH4 that I have, I want to find out the moles of H2O that amount of CH4 on this side is going to give me. We can use the equation to find out the relationship here. If there's not a number in front of a molecule on an equation, it means that the number is 1. So this means that I have one CH4 molecule gives me 2 H2O molecules, or I can think of this in terms of moles. 1 mole of CH4 gives me 2 moles of H2O. I want to make a conversion factor of that, where I show 1 mole of CH4 gives me 2 moles of H2O. Here are the 2 possible conversion factors that I can use. Which one do I want to use? Well, I have to start with my moles of CH4, 2.60 moles of CH4 times which one of these do I want to use? I want to use the one with CH4 on the bottom so that it will cancel out those units and it will leave me with units of moles of water. So I'm going to do this times 2 moles of H2O divided by 1 mole of CH4. Moles of CH4 up here cancel out with the moles of CH4 down here, and I'm left with moles of water, which is exactly what I want for my answer. This is pretty easy math. It's going to be 2.6 times 2 divided by 1, and I'm going to get 5.20 moles of H2O. That's the answer to my second step. Now I know that I have 5.20 moles of H2O. Now the last thing that I need to do is I need to find out the mass in grams of 5.2 moles of H2O, because that's what my question asks me. In order to do that, I'm going to have to use the molar mass, which tells me the weight of 1 mole of water. I do that by adding up the weights of the individual atoms. I have 2 hydrogens, which weigh 1 each, plus 1 oxygen, which weighs 16. Add this up and I get 18 grams is how much 1 mole of water weighs. Just as before, I can express this actually in 2 ways. I can do 18 grams over 1 mole or 1 mole over 18 grams. I'm going to start with 5.20 moles of H2O. Which of these conversion factors do I want to multiply by? I want to get rid of moles, so I'm going to use this one here on the left so that I have moles on the bottom to cancel out. So 18 grams divided by 1 mole. You may notice that sometimes I write it with E, sometimes I don't. It's no big deal. It's usually just when I write MOL, it's because I'm feeling lazy, but it's the same thing either way. Anyway, I have moles up here, moles down here. They cancel out, and I'm left with grams as my unit, which is perfect because that's what I want. And the math I'm going to do is 5.2 times 18 gives me 93.6 grams of H2O, and that 93.6 grams H2O is my final answer. Let's just quickly review the steps that we went through to do this. The first thing that we did is we converted our 58.2 liters into moles, and we could take advantage of that 22.4 liter rule because it was at STP. That gave me the moles of CH4. Then I took the moles of CH4 and I found out how many moles of H2O I'd get. Then I got the answer for that. And finally I took the moles of H2O and I used the molar mass, 18 grams per 1 mole, to find out the mass in grams of water that I'd end up with at the end. One thing that's really important to keep in mind is that you can only use this rule, 1 mole of gas taking up 22.4 liters of volume, if the conditions are STP, which is 0 degrees Celsius and 1 atm. If the temperature or pressure or both are different, you can't use this 22.4 liter rule, and you'll have to use the ideal gas law to calculate the amount of space that the gas would take up. If you need to do that, check out the examples that I have on gas stoichiometry that are a little bit harder.